Hi, in this video we're going to have a look at this Yihua 853A preheating station. So what this is it's a preheater for your PCB, so you can clamp your PCB in the top here above the ceramic heating element, and it allows you to raise the temperature of the whole PCB up to somewhere between 50 and 350 degrees depending on what you set on the dial on the front. And then that means that you can more effectively work or rework any components on the board, because you've effectively got the entire board, let's say up to 150 degrees C, where it can remain quite happily there for a short period of time. And essentially then when you work the components with your hot air tool or with your soldering iron, you've only got to raise the temperature up by 50 to 100 degrees in order to melt the solder. So that means that the actual rework time is a lot shorter, and you're subjecting the components on the board to a lot less thermal stress because the whole board has been slowly raised up to that temperature. So this is currently retailing for about £85 on Banggood, and this is rated for approximately 600 watts at 220 volts. I don't think they do a 110 volt version on Banggood anyway, and it allows you to work on PCBs up to around 10 by 10 centimeters, I think, is the size of the ceramic heating element. And it has these nice clamps which allow you to clamp your PCB in place depending on how big the board is. So on the front here we've got the power switch at the left hand side. We've got a dial here which allows you to adjust the temperature, and then there's a button here which allows you to display either the temperature that you've set on the dial or the actual temperature of the ceramic heating plate. So it's got quite a nice construction, much better quality than I was expecting actually from the pictures. It looks like it's got 4 screws on each side and then one on top to hold the cover on. And just at the back we've got a fuse and a mains inlet with an IEC connector, which is nice, so you don't have to faff around with the cord permanently attached. And then just the detail on top. So you've got these sliding bars, you can undo the knobs and move these around. And what that lets you do is clamp your PCB in place in the little grooves that are there. You tighten it up, and then you're free to work on the board, set it to whatever temperature you want, and then you can just use your hot air tool to pick off devices nice and quickly. So the actual hot plate area is actually 120 millimeters by 120 millimeters, but obviously if what you're working on is a bit bigger, so long as the components are within that area, you can actually clamp slightly larger boards. So just looking at the inside, this is actually not bad construction at all. So we've got the IEC inlet at the back here with an earth cable that goes straight onto an earth lug onto the chassis, so that's all good. We've got the live going straight to the fuse holder and then off to the front panel switch. And then that goes to the PCB, where there's presumably, it looks like a triac here for controlling the power to the heating element, and then back off to this transformer which supplies power to the logic on the PCB. And it's quite a good choice actually to use a standard EI core transformer in something like this, because we've got this ceramic heating element that will get quite warm, and something in the vicinity like a switch mode power supply that has capacitors that do dry out and do need to maintain their high ripple current rating is likely to prematurely reach its end of life. So something like an EI core transformer that isn't really that sensitive to heat is quite a good choice here for the application. So I mean, in terms of longevity, unless the ceramic heating element burns out, this is going to last a very long time. So everything's got this I think it's silicone, it might be fiberglass tubing on here to improve the heat resistance of the PVC cables. Yeah, they are PVC. And then we've got the heating element here, which obviously is mounted to the back panel here. And then at the front here, we've got our control PCB. So I'll see if I can get the camera in at a slightly better angle. Right, so what we've got at the bottom here is the AC coming in from the transformer. So this is the extra low voltage AC from the transformer going straight into a bridge rectifier, and then this device on the heatsink here is a 7805 regulator. We've then got a couple of wires here, the red and black ones, which go off to a temperature sensor that's on the heating element. And then we've got couple of wires here which go to the potentiometer at the front. And then the whole thing that's running the show is a 6062 processor, so a pretty basic processor, but it's not doing anything too complex, just doing some very basic, it will be a bang bang control loop for controlling the heating element. And then we've got a triac here with a snubber, so a capacitor and a resistor to help with the transients. And then we've got an optocoupler so that we can drive this triac driver from the microcontroller from the extra low voltage side. Looks like we've got a trim pot here which might be for trimming the temperature values, and then there's not really that much more to it. It looks like we've got a little op amp snuck in here that's for the input from the temperature sensor, but yeah, not really much else. We've got a couple of pins here which go after the 3-digit LED display, and that looks like it's just being driven directly from the microcontroller. Okay, so we've hooked it up to the mains, and I've got the thermocouple sat right underneath the PCB. I'm not sure whether the temperature is going to be calibrated for that of the actual heating element or roughly what the PCB will be at. So we'll find out. Let's turn it on. And we've got the temperature set to 150 degrees. And we should be able to watch this climb. So the hot plate's reached 150 degrees now, and it looks like the PCB's settled at around 47 degrees. It's struggling to get a bit higher than that. So we'll try turning up the temperature a little bit further. Right, so the device says it's up to 350 degrees, but the thermocouple that's on the plate isn't anywhere near that. And interestingly, the hot plate isn't actually that active. You can see the little dot on the front panel which is saying when the hot plate is actually turned on, and it's not doing 100% duty cycle. So there is more heating capacity available. So it looks like it needs some calibration, or something has gone wrong with the temperature sensor on the hot plate. But the board has got up to around 90 degrees C. Let's turn it up to the maximum 400 degrees C, and then what we'll do is we'll quickly just get the hot air gun and just see how quickly that helps with removing some of these small components. Right, so we've reached pretty much thermal equilibrium, so let's try heating up some of these little 0805 components. And these should lift off pretty quickly. There we go, yeah, look. Really quick. So you can see if we had some chips on the board, they would come off very, very, very quickly without needing to thermally stress sort of the whole board with heating in a very localized area for quite a prolonged period of time. So it does work quite well. Obviously we're not up to the temperature that we should be, so I'm going to do a little bit of investigation just into this unit to see if it can be calibrated or whether this one's faulty. Right, so it looks like we're pretty much spot on actually. The fluke, for whatever reason, these thermocouples always have trouble reading these kind of things, but we've got 350 set on the front and it's accurately reading 350 degrees C here. For whatever reason, when you set this to 100 degrees, this is spot on and this is spot on, but at 350, we just don't seem to get an accurate measurement with the thermocouple. But we are reading the right temperature here, so it just needed a very minor tweak, literally a quarter of a turn, and we've got pretty much bang on the right temperature. And yeah, it seems to be working how it should be. Yeah, so if you want to have a look at this product on the Banggood website, the links are down below in the description. Don't forget to look out for discount codes as well if you are interested in something like this, but we'll explore it a little bit more in the next video where we reflow a entire little PCB with a solder stencil and some solder paste. So hopefully you enjoyed that video, and until next time, thanks for watching.